Welcome to Chemistry Made Simple. Today we are going to continue with our topic that we started. That is redox reaction. Today is another section. We are going to tackle another section, which is also very technical, but the continuation of the topic we left behind after the solution of our problem. Now, we are going to look at a subtopic, the concept of oxidation and reduction in terms of change in oxidation numbers. The concept of oxidation and reduction in terms of change in oxidation numbers. So today we are going to look at technically the process of oxidation, the process of reduction in terms of change in oxidation numbers, and we are going to conceptualize that. Now let's look at the first point, which is oxidation process. So oxidation. Now we are going to look at it in terms of change in oxidation numbers. When we talk about oxidation process in redox reaction, in terms of oxidation numbers, we are going to look at increase. So when there is an increase in oxidation number of a particular element in redox reaction, then we can vividly say that oxidation has taken place. When there is an increase in oxidation number in a particular element, compound, substance, then we can say that oxidation has taken place. So technically, in a redox reaction, so increase in oxidation numbers in elements in a redox reaction is what we term as oxidation. Now let's pick a technical or a typical example. For example, we can have Fe2 plus produces Fe3 plus. Now, this is iron 2 iron. This is iron 2 iron. Produces iron 3 iron. Now, what can we see over here? We can technically see that the oxidation number for iron 2 over here is plus 2, or the iron is what? Plus 2. And over here is plus 3. So here you can see that since iron increases its oxidation number from plus 2 to plus 3, then we can say that oxidation has taken place. Oxidation has taken place because there is an increase in oxidation number. So technically we can say that Fe2 plus increases from plus 2 to plus 3 in Fe3 plus. Therefore, oxidation has taken place in Fe2 plus. So oxidation has taken place in the Fe3 class. Therefore, we can say that Fe2 class is said to be oxidized. And therefore, it is a good reducing agent. It is a good reducing agent. We can say that Fe2 class is oxidized. So you can say hence Fe2 plus is said to be oxidized. And it is a reducing agent. So it is a reducing agent. Now we have Fe increases from plus 2 to plus 3. Therefore oxidation has taken place in Fe2 plus. Hence Fe2 plus is said to be oxidized, and it is a reducing agent. So it is a reducing agent. Now let's look at the next example. Now in the next example, we are going to look at, so let's balance the equation. Let's balance the equation so that it will be very clear. Here we are going to add 1 electron to the right hand side of the equation. Remember, I told you that when we are considering oxidation process, the technical idea is that we add electron to the right hand side of the equation, or the product side of the equation, to balance the equation. So here you can see that I've added an electron, so that at the end, the whole of this, at the product side, you have plus 2, and then at the reactant side, you have what? Plus 2. So this indicates that there is a balance. This minus 3 will give us plus 2, which is equal to this at the product, at the reactant side. So the next example. We will look at Cl2 produces Cl minus. Now we have to balance with a value, because this one chlorine is 2, so we put 2 over here. Now what can we say about that? Here we could see that this place is 0. So chlorine is that of what? 0. And then that of, here we have Cl minus, which is what? Negative 1. So we have seen that there is what? A decrease. So chlorine is 0, and then it is negative 1 over here. What does it see, or what does it implicate? Now this implicates reduction. The idea of what? Reduction. Therefore, we will technically look at the second idea, which is reduction. So reduction is a process. We are going to look at it mainly. Now here we have decrease. Decrease in oxidation numbers of elements in a redox reaction. Decrease. Now, decrease in oxidation numbers. So we are going to look at a decrease in an oxidation number. So a typical example is what I started, the introduction. When I was going to introduce the reduction process, I gave you a typical example. Then I asked that what is happening. We have a decrease. So we have chlorine produces Cl minus. Now I'll put 2 so I can balance the number of molecules. Now what can we say? Here we have 0. So it means that the charge of chlorine over here, chlorine molecule is 0. And then this place is what? -1. Technically, we can say that chlorine decreases from 0 to -1. So Cl2 decreases from 0 to -1 in Cl minus. Therefore, reduction has taken place in Cl2. Reduction has taken place in Cl2. Hence, Cl2 is said to be reduced, and it is an oxidizing agent. So Cl2 decreases from 0 to -1 in Cl minus. Therefore, reduction has taken place in Cl2. Hence, Cl2 is said to be reduced, and it is what? An oxidizing agent. Now, that is technically the concept of oxidation and reduction in terms of oxidation numbers. So, we have now come to look at these two ideas, which is oxidation and the what? Reduction. Now let's balance the second example, which is under reduction, which will be the first example under reduction, but the second example to be considered under the whole concept. So here you add plus electron. How many? Plus 2. Add plus 2, so that the whole system will be balanced. Now we have a very balanced equation over there. Now let's look at problem solving. Let's look at one typical problem and then see how best we can solve it. Now I'm going to pick a very technical example from our normal or our day in and day out problems, like this one, problem 1. So we want to pick a problem and then start with the application of the ideas. So we are going to look at problem 1. So we have problem 1A. So we have our first problem. We have says with the use of oxidation numbers in each of the following reactions. I'll add the rest of the reactions. State the names of the oxidizing agents and the reducing agents. So here we are going to look for oxidizing agents and the reducing agents. Remember, we have already done how to identify the concept of identification of oxidizing agent and the reducing agent. We said if you want to look for oxidizing agent, you go in for the substance that is what reduced. If you want to also identify reducing agent, you go in for the substance that is what oxidized. That is why over here, the substance that was oxidized was the reducing agent, and then the substance that was what reduced was the what oxidizing agent. That is how we determine that, or we identify that. So we are going to pick the reaction one after the other. First, we are going to balance it. We have NaCl2. So this one, chlorine is 2. Chlorine is 2 molecules over here. So we have to find a way of making it 2. Now, in doing that, we have increased the number of what? Na. So you can also put 2 here, so that Na will be 2, chlorine will also be 2, and then the system will be what? Will be balanced. Now, what we are supposed to know is that here we have chlorine over here, we have sodium over here, so we have Na. Na has how many charge? We have 0. Has it changed? Is there any change? Let's write an ionic form for it. That will help us. We have Na, and then we have Cl2, and then produces, let's write an ionic species for each. So we have Na plus, and then we have what? Cl minus. So when you look at it ionically, that will be what will be produced. So when you look at it ionically, that will be what will be produced. So you can see that here 0 will be here, that will be 0. So we are going to look at which substance undergoes the process of oxidation, which substance undergoes, so that we'll be able to determine the oxidizing agent and then the reducing agent. So I'll first pick Na. Na, you can see that is 0, and then it increases to what? +1. So oxidation. So the oxidation half. We have Na. So Na, we have from 0 to +1. So the oxidation numbers, we have Na from 0 to 10 +1. So it means that here there has been what? An increase. Therefore, it is an oxidation what? Process. Once it's an oxidation process, then we can say that Na is oxidized. Hence, is a reducing agent. So here, Na is the reducing agent. Now, let's look at the next one, reduction. So reduction half. We have Cl2. So what happens? From 0 to -1. So here too we have what? Cl2 is reduced. Hence is an oxidizing agent. See, Cl2 is what? Is reduced and is an oxidizing agent. So you can see that technically here we have been able to determine the substance which is what? The reducing agent, and the substance which is what? The oxidizing agent. Now that is technically how we use this idea to solve what? Problems of a sort. Now let's look at the second problem. That is B. We have Zn plus Cu2 plus produces Zn2 plus Cu. Now, solution. Here we want to determine the oxidation half and then what? The reduction half. So oxidation half. Now we are going to look at the oxidation numbers. Zn is 0 and then it is plus 2. So it means that there has been what? An increase. So Zn that is from 0 to plus 2. From 0 to plus 2. So this indicates that Zn is the oxidation half. So we can say Zn is oxidized, hence is a reducing agent. Now let's look at the reduction. Before we look at the reduction, maybe let me write the oxidation half equation for you to know. So we have Zn produces Zn2 plus and then balance it. Here I'll add electron. How many electrons? 2. So this is the balanced half cell equation. This is the balanced half cell equation. We'll come to that. So we have the reduction half. Reduction half, we have Cu2 plus, from plus 2 to 0. See, a decrease. So we can say that Cu2 plus is reduced. Hence, is an oxidizing agent. Wow, this is very nice. So the half cell equation will be Cu2 plus produces Cu. So I'll add plus electron here and then 2. Now this is the balanced half cell equation for the reduction half. Today we have come to study the concept of oxidation and reduction in terms of changing oxidation numbers. And then we have come to the various conclusions. We have been able to also solve problems under that. Now, in my next meeting, we will solve additional problems. And then we will see how best we can apply this concept to various problems. See you in my next tutorial. Welcome to Chemistry Made Simple. Bye-bye.